So, good evening, sir. Good evening, everyone. My name is Aditya Sinha. My seat number is B1509530004. This is machine learning oral examination where I have been appointed about to explain about the logistic regression with on the book of Python machine learning with page number 62 from page number 62 to 65. The book details are the name of the book is Python machine learning by the author Sebastian Rachka and published by Packet Publishing, and its copyright is up in 2015. So basically, talking about my this PPT is it's all about the machine learning. Machine learning is the study of computer algorithms that improve automatically through experience and by the use of data. It understands how we have to know what it need to be predicted, and it gives this PPT will give you a basic understanding how Python is being used to improvise the tools and the methods required to build the system with easy methods. And coming to the point that what this PPT is about. So this first let me start with what is regression. Regression analysis is a predictive modeling technique. In this technique, we predict by some methods by some models where how given from the given set of data, the we have to predict what will the result, and it establishes the relationship between the target and the predictor, which is in mathematical terms you'll consider that a y value is the result and x value has been is the predictor, which can be in more or more values ways. And talking about the types of regression, there are various types of regression: linear regression, logistic regression, and polynomial regression. Coming to the main agenda over here is logistic regression. It is a fundamental classification technique which used to obtain the odd ratio in the presence of more than one or more experimental variable, and it is a predictive analysis. And in this logistics regression, we I am using Python programming. Python programming is a integrated high level purpose programming language. It is very simple and easy to learn. It is by by line coding, and in machine learning, since machine learning is a high level and complex algorithm and workflow. So by using Python programming, we can make those complex algorithms into simplicity, and everybody can understand the code by line, and there is no high level uh, coder needed to brief what is being done in this project. In this PPT, which I have shown with example, I have imported the Skykit learn package. In this regression model, it, it's mandatory to use the Skykit learn package, so that it is easy to make the classifier and workable, which can give me various benefits like pre-processed data, validate models, solve recursion and classification problem, and implement cluster analysis, for where machine learning will be easy and give 100% efficiency, and it is very optimized version of logistic regression for Skylearn package importing. Coming to the topic which sir has been appointed, is been training a logistic regression model with uh, Skyset Learn. I have been since so simply I have it's simply a substitute of the cost function j. The jw is a uh, summation of y log of sigma to the z of plus 1 minus y log of whole of 1 minus sigma z. Which this is the uh, defined formula for the regression logistics, and this would compute of cost of classifying all training samples per, and it and working and giving the 100% result working result. However, since sklearn implements a high optimized version of logical regression that also supports multi-class setting of the cell, and so it is needed to be used. The main package line I am using here is a sklearn.linear model logistic regression class, which will import all the data sets, and the package will be imported and it will make my work easier. So after the fitting of the data and decision making is been done by the machine learning by this skykit sorry by the scikit-learn package, which is used by the python, we'll be getting a graph, or where it will be a brief in the result, where how it is been classified in multiple categories based on the requirement. And furthermore, if we predict the class membership probability of the sample via predict and proba method. For example, we can predict the probability of the some requirement or the problem statement, where we want that in this percentage or percentage what do we want result, and other percentage what do we want. uh, the data set will be in the form of array and structures. In whatever preceding array tell us the model to predict by how many percentage they needed. And now I'll be going to the my uh, example code which I have taken as a case study. So you can see a link given here for the Python, which is being made in Jupyter Notebook in Google Collaborator. Let me open over here. So this example is basically an image recognition, where I have it's a recognition of handwritten digits, where a data set of 1797 observation, each of which is an image of one handwritten digit. Each image has 64 pixel with a width of 8 pixel and height 8 pixel. The inputs, so has a step one, has in code I have mentioned. Package has been imported like matplot for plotting the map, numpy for numerical subs, and the sklearn packages, which are described as sklearn dot respective package names. And in the next step, I have taken the data sets, which is data set which is directly from the sklearn package, with using lot underscore digit, which returns a tuple of inputs and output. If you see the result, it gives me the multi-dimensional array with 1097 rows and 64 columns. As I mentioned earlier, what is image about the image. Then then again I'm split, and in this method only I'm splitting the data for the training set and test set. So because this split of data is been usually performed randomly, so I'm training using a training set model. And now I'll be fitting the model by applying the syntax train underscore test dot split, and as you seen in the code. This train underscore test dot split accept the x and y. It also takes the size of the test, which determines the size of the test, and the random state, like pseudo random number generators, which are the garbage value if generated. This function returns four types of arrays, which are x train, x test, y train, and y test. Talking about the train part, which is the fit model in x and y respective, and test part is the evaluate model in the expand x and y respective. Now I will doing the now if you see the data scaling of data, this is the basic process of transforming data in a such way that mean of each column becomes equal to 0 and standard deviation of each column is 1. So in the code I have been using the dot fit underscore transform to bring the scaling of data via standardization. Now in the code I'll go below, so you will be see there's a model I have been creating, with x underscore train and y underscore train to fit it into the code, and then later on I will calling it with dot fit. But before that I will creating an instance for the logistic regression. Now when we are working with the problem, there are two classes or more than two, so we need to specify those stuff like multi-class parameter or of logistic regression. Now in the next step, that's the fourth step, I will evaluate the model by using the x underscore test and y underscore test, and the code is x underscore test is equal to scalar dot transform, where I will obtain the argument without fitting the scalar. Similarly, for the uh, y model, y scalar I will do with predicting. For prediction, I will using the y underscore predict and equal to model dot predict. The model dot predict will give me the prediction. So if we check it out, for the train part x and y there is a model score, and for the similarly for the x and y there is a model score like has given below 0.94166. Actually we can see that the two values of the accuracy, one obtained with a training set and other obtained with a test set, has mentioned earlier. So now I will be making a combined matrix of this dataset, this test and the train dataset. Now it after confusion underscore matrix, the test and the predict is been generated, and it's been in 100 numbers in a matrix. Now the other patch of code is Python code, where I will be using a visualization to visualize this with complex confusion matrix into image, where a graph where we can analyze easily without wasting of any time. So the result below shows that the actual input, how many times the zero number is been inputted, and how many times predict or output what after entering the zero, how many times the zero or one has been come. So above map shows the confusion matrix with number and colors. The shades of the purple represent small numbers like 0, 1 and 2, while green and yellow shows the large numbers, we can see diagonally 27, 32, 33, and so on. So these numbers correspond to the incorrect prediction. For example, the number 1 in the third row and the first row shows that there is one image, with the number 2 indirectly classified 0. So finally we can get the report of classification directly, and below is the print by using print of the classification underscore report, shows the complete uh, what I say this example report in a tabular form. So coming to the uh, conclusion of this PPT, I'll just say that logic regression is a statistical technique for binary classification, and when we are creating a machine learning model, the most important requirement is the availability of the data. Has shown earlier that we don't need to export any data. The data can be imported from the skyscape learn packages without adequate and relevant data. We learn how to use a logistic regression classifier provided in the this sklearn library, and to train the classifier, and the rest of the data can be used for the testing, and we can have a accuracy of the model, 100% accuracy of the model. Thank you.